Hello everyone. In this video, we will show you how to work in the ENCY Hyper application, from creating cells to connecting with a real robot. To create a cell, you need to use the MachineMaker application, which contains a large library of mechanisms. After launching MachineMaker, you have to go to the mechanism library. Switch to online mode and sort through everything you need. In this example, we will add a robot, a tool, and a table. Also, in this window, you can move the robot and you can connect the robot to the table. For this, hold down the left control button and drag it to this red connector. To move objects freely, hold down the left Alt key and drag the mechanisms with the mouse. Done. We can send this cell directly to ENCY Hyper by clicking this button. When you export your project from MachineMaker, MachineMaker will close automatically, and your project will open in ENCY Hyper. This is the cell window. Here, you can add various objects you need, change their parameters, and add connectors to those objects to later place your parts on them. Now, we have edited the parameters of our table, which we need. After clicking the Apply button, we can move and adjust our object. Once we have moved it, we'll add a connector to our table. We'll add a double connector. The parameter called Stack Levels controls this option, then click Apply. We'll also add a second table, with approximately the same characteristics. And we'll add two connectors to it as well. Click Apply, and the Cell tab is ready. Next, we move to the Parts tab, where we can both import and add prepared parts. Let's add the next part. Here, just like with objects, we can edit various parameters for our parts. Apply button, and move to the next window, where we can view our connection points and place our parts there. Here, we have two parts located on different levels, which we need to move onto another table. For that, we need to switch to the Programming tab. This tab is responsible for debugging our program and adding commands. In this window, we can use the following commands. Before starting, we need to set up the project and robot parameters in order to connect to it. The next parameter controls the robot's speed. And it needs to be adjusted. In the Programming tab, we should configure it as shown, then press the Apply button. Our project is ready. Now we need to add commands for the robot to move our parts. For this, we use the pick command. And we'll disable the single element toggle so the robot understands it will be working with two or more parts. Next, we add the place command so the robot knows where to put these parts. After that, to make the robot understand what to do if the table is empty, we need to add conditions. Add parameters so that if the table is empty, the robot must go to the start point. Then, go back to the start point, press the Start button, and recalculate the project. Once you've recalculated your project, you'll see the robot's motion path and can use the speed slider to watch the simulation. In this case, the robot picks up our part and transfers it to the specified connector that we set in the Cell tab. From this simulation, we can see the robot has successfully completed its tasks, and we can now connect to the real robot to check how it will operate. To do that, we need to go to the Run tab. In the program's Launch tab, we only need to press the offline button and connect to the robot. After a successful connection, a red online button will appear. This means you are connected to your robot. To check how your robot will move, simply press the Start button. You can adjust the speed, and as we can see, the movement path in the Hyper application matches exactly with that of the connected robot. The robot delivers the second part and returns to its home position. At this point, we can press the Stop button to finish the program.